Hello everyone, welcome once again to my lecture on differentiation from first principles. So in the last lecture, we found out the differentiation dy by dx where y is equal to x, and we said dy by dx is a constant. Dy by dx here in this case is y. So if we have any constant, say a in front of x, dy by dx will be equal to that constant a. Now what happens if y is equal to a constant a? So dy by dx in that case will be equal to 0. Why? Because y is equal to a is basically a straight line. If this is y is equal to a is a straight line, and we all know that dy dx is nothing but the slope of a straight line. So slope of a straight line is equal to 0. Okay, now let's see what happens if we have y is equal to x squared. So let's draw this curve. This is x-axis and this is the y-axis. So this is the curve y is equal to x squared. Okay, let's take a point P, x and y, and a point Q, x plus delta x and y plus delta y, as in the previous example where we all know that the displacement on the y-axis is delta y and the displacement on the x-axis is delta x. Now since this is a curve y is equal to x squared, so x and y should satisfy this equation. So we can rewrite this as the point x and x squared, and we can replace this y in this one by x plus delta x whole square, right? Because here x in this case is x plus delta x, so if y will be equal to x plus delta x into whole square. Now we all know that the slope at the point P is defined as dy by dx is equal to the limit as delta x approaches 0. As delta x approaches 0. So as delta x approaches 0, we are going along this curve and we are approaching, the q is approaching the point P. So this is delta x tends to 0 of delta y by delta x. So this is the tangent delta y by delta x. Okay. So this is equal to, what is delta y in this case? This distance minus this distance. So it is this minus this. So it is x plus delta x whole squared minus x squared upon x plus delta x minus x. So we get here limit as delta x tends to 0. This is, if we expand this expression, this will become x squared plus 2x delta x plus delta x of whole squared minus x squared upon this, and this will cancel. So we'll be left with delta x. So we are left with delta x, limit as delta x tends to 0. This is also cancelling off. We get 2x delta x plus delta x whole squared upon delta x, which is equal to limit as delta x tends to 0. This divided by this, we are left with 2x plus delta x. Delta x whole square divided by delta x, we will be getting delta x. So as delta x tends to 0, this part will be approaching 0. So the limit dy by dx now will be equal to 2x. So we can say here, when y is equal to x squared, dy by dx is 2 or x. Okay. So if y is equal to a constant multiplied by x squared, we can just multiply the constant by expression. So if y is equal to ax squared, dy by dx will be equal to 2x. Now let's see what happens when we replace y equal to x squared by y equal to x cubed. It is simply that we just have to change all these expressions to a cubed form. So this will be changed to a cubed form. Now this expression will change only. This will remain delta x. So what is x plus delta x whole cube? We all know that this is equal to x cubed plus 3x squared delta x plus 3x delta x whole squared plus delta x whole cubed, and the last expression is x cubed. Okay, now this x cubed and this x cubed will get cancels off. Okay, so we will be left with here 3x squared delta x plus 3x delta x whole squared plus delta x whole cube by delta x. So the final expression we will be left with is 3x squared plus 3x delta x plus delta x whole square. Now we know that delta x tends approaching 0. This expression will approach 0 and this expression will approach 0. So finally we are left with 3x squared. So when y is equal to x cubed, dy by dx will be equal to 3x squared. Now if we have to have a constant here, it will be a and a constant a. Now you see a certain pattern is, we are getting a certain pattern. As you see, we are getting a certain pattern. So let's say we have an expression a x to the power n. So what will be dy by dx? dy by dx will be equal to, we are multiplying by 3, a is remaining, x is remaining, and the power is getting reduced by 2. So a is remaining, 2 is this power, and x we are decreasing the power by 1. So what we are getting is dy by dx will be the power multiplied by a multiplied by x, and the power will be decreased by 1. So this becomes the general formula for differentiation. Okay, so taking this formula now for differentiation, we can solve many problems on differentiation. So let's take some examples. Y is equal to 6x to the power 4. So what is dy by dx equal to? Dy by dx is equal to 24x to the power cube. 4 multiplied by 6 is 24. X decrease the power by 1, that is x cubed. Okay. Let's take another example. Y is equal to 1 upon x to the power 5. So dy by dx will be equal to x to the power 5 means x to the power minus 5. So it will be minus 5 x to the power minus 6. So it means this is equal to minus 5 upon x to the power 6. Okay. Y is equal to 3 by 4 x squared. Okay. So this is equal to 3 by 4 x to the power minus 2. So minus 2 will be multiplied by 3 by 4. 2 will get cancelled. So let's write it, minus 2 multiplied by 3 by 4 multiplied by x to the power minus 2 minus 1. So we get what? This and this will cancel off. So we are getting minus 3 by 2, and this is x to the power minus 3 will go down to the denominator as x to the power 3. Okay. Let's take another example. Y is equal to x to the power 1 by 3. So dy by dx is equal to here we are having dy by dx is equal to, right? So dy by dx is equal to 1 by 3 x to the power 1 by 3 minus 1. So this is equal to x to the power 1 by 3 minus 1 is minus 2 by 3. So we get 1 upon 3 to the power x power 2 by 3. Okay. Let's take y is equal to 1 upon root of x. We can write simply this one as x to the power minus half. Therefore, dy by dx is equal to minus half of x to the power minus half plus 1. So this means it is minus half to the power x to the power minus half minus 1 is minus 3 by 2. Okay, we can write this simply as minus 1 upon 2 to the power x to the power 3 by 2. Okay, or we can also write in this way, minus 1 upon 2, okay, square root of x cubed, whichever way you want. So these are some problems that I have solved on differentiation, applying the general formula for differentiation. Okay, this is all for this lecture. Till we meet in the next lecture. Thanks for watching.